Right, hello guys, I'm back again with another update for my analog DIY synthesizer project. And what we have here, I'm going to talk you through the envelope generator which I have built. This is probably about the fourth one I've built and actually got it to work properly. It has a gate trigger here, so we have a manual button which draws the power from the power rails and sends the pulse, which initiates the envelope. Indicator light over here, and also I have a potentiometer here which allows for a net. You can have if we have it full that side, a positive envelope. If we bring it this side, turn it this side, we have the negative envelope. And it's pretty much based around this 5.5. I don't know if you can see that, sorry, my camera's really badly losing focus here. This 555 timer IC, which is here, and I'm just going to quickly show you the schematic, which is here. And I've made a few modifications on this, as you can see. This is a trimmer which I put in, which it did recommend using a 10k resistor. What I found, I was getting quite a hard bump when you could hear the pulse bumping as you was releasing the gate trigger button. So I've put a potentiometer in there so I can actually trim that voltage in, so it's not necessarily 10 volts. It still works well depending on your power supply, I guess. So I think it's actually recommended. This is another one which was from usynth .net, I think, could be .com, and basically we have some diodes just for protection and stop it bleeding back in, the currents bleeding back into other circuits. And I'm sending this at the moment to the CV input of my second VCF, which is the Steiner Parker VCF, and also I've patched that in to this side over here, which is my VCA, just this section here with this quad op amp IC. Again, another quad. All these ICs are basically quad op amps. You can use TL 084s, TL 074s, and I'm sure there's some better quality ones out there, but these are pretty much, this project is just supposed to be inexpensive, pay as you go kind of thing, so I'm sort of buying bits as and when I can afford them. What also I have is a trimmer which basically bypasses the I think it's here, which allows the envelope time. You could either have it slow or fast. So basically I thought, well, why have 120, why have a switch? You can just put a potentiometer which pretty much covers both of these values and just adjust it to taste, really. Also on the 555 timer here, we have this discharge capacitor, which has a lot to do with the timing or the drainage of the timing. So the higher value of capacitor that you use, I found out, the longer release time you can have. So if you actually went by this one here, you'd have a very, very short release time. So I found by using I think I went up to about 220 microfarads. So it gives you a really, really, really long release time. Also the sustain part, it recommends using a 10k potentiometer or variable resistor. I've used a 47k, so I've just basically been playing about with bits, swapping values around to see what works for me. You don't have to necessarily strictly go by some of these schematics, as long as you keep the basics pretty much the same. Other things like these values which affect timing, you can kind of mess around and see what works best for you. We've got an indicator light here which shows you a representation of your your envelope. I'm just going to power this on, and if I hit the gate trigger, it's going to turn this release all the way down. Just hit the gate trigger, you can see that light lights up straight away. Let go of it. Got minimum attack, so 0 attack, and decay is at maximum. I'm going to add a little bit of release in there, so it's pretty much behaving like a piano envelope. Let go, and you can see the light fades away, and we can have even longer release. Now this is patched into the VCA, which is over here. I'm not going to talk too much about the VCA in this video because I haven't actually got a lot of time for this clip. So quad op amp here. The VCA is basically triggered, or the CV input from the envelope generator goes into here, where you can see this 47k resistor goes into the inverting input, and that initiates the VCA according to how you set the envelope, so it will respond exactly to the envelope. And then I've gone into what I have here is a wavefolder, which if you Google CGS wavefolder, it's one of the simplest wavefolders you can build. It basically runs off 2 transistors, one being a PNP, one being an NPN, so you can use again common parts easily obtained, anything like a 2N3906 for the PNP or 2N3904 for the NPN. Or you can use a BC547s, etc, or BC184s, 18, any PNPs and NPNs should work pretty much. What I have done on this one is gone to 2 different stages, so I've basically duplicated the wavefolder stages as an experiment, just to see how well that works, if it gives me more folds, and in turn creates more harmonics as you change, because basically the wavefolder will be responsive to the amplitude of the input signal. So I think it kind of works on saturation. So say for instance we have a set level, the wave which will normally, say for instance just triangle, will hit the saturation point, and then it will be folded in on itself, and this creates extra harmonics. I mean, this pretty much, they say use a triangle wave or a sine wave because it doesn't have much harmonic content anyway, but this works really well to create some unique sounds, even if you're running, say for instance, a sawtooth wave, or even a square wave with pulse width modulation. Really makes some interesting sounds. And yeah, and that's pretty much it for this video. So I'm going to be showing you in my next video just the small MIDI to CV converter that I built here, which is using an Arduino Uno R3. There's a circuit on the internet, again you can grab this. Again, it's quite simple. We have a opto coupler or opto isolator, which is a 6N138, so write that down if you're looking to build something similar. And also I'm using the MCP, I think it's a 4921, which is a 12-bit DAC. So, and that is being powered. You can either power it from USB, but I've built a reference voltage which is a higher voltage than the one that the Arduino gives out. So I'm in the process of building that at the moment and testing that to get it working. I've kind of got it working, but it doesn't scale perfectly. Expo converter for the oscillators. We can send the control voltage in from many different sources, etc. So yeah, and that's it for now. Alright, I'll be back no doubt. Any questions, please leave them in the comments. I'll leave a very short description, so have a look through the other videos and just find out what's what. as I've been going along, and I will see you all guys soon.